What's up, everybody? Welcome to this tutorial on how to calculate expected threat. So expected threat is a really popular metric right now. It's something that a lot of Twitter analysts and a lot of journalists are starting to use in their analysis of soccer, football, call it whatever you want. Point being is that it's a very popular metric, and it's something that in my opinion will only continue to gain popularity because of the simplicity of it. So if you don't know what expected threat is just basically taking and giving value to how players contribute to an attack independent of the outcome. So normally we just have shots and we just have assists, but this is actually giving value to people when there may not be a shot at the end of a sequence of play. So it's giving value to people who are progressing the ball, who are moving the ball into more dangerous zones. There's a lot of great reading and a lot of great videos that you can learn more about this. This isn't a video that's going to really go into what is expected threat, but more of showing you how you can calculate this within Python. So I would recommend that you at least read these 3 articles. The first one is this one by Karan Singh. He goes over and kind of introduces expected threat. This is kind of where expected threat became known to the masses. And then as well, if you have an athletic subscription, you should read this one by Tom Warville. And really this article from Tom has kind of started the new wave of what is expected threat and kind of introducing it to even more people. And then as well, David Sumter, who does great, fantastic mathematical work. He does a really deep dive into expected threat, where it originated from, because as you can see, it originated, like he says, back in 2011 by Sarah Rudd using Markov chains, which is kind of just a mathematical framework of assigning values and probabilities and everything. So I would recommend that you go through these 3 articles and watch this video as well. And David's, this is from Friends of Tracking, their YouTube channel. So be sure to check that out and just kind of familiarize yourself with expected threat and learn the basics of expected threat, because being able to calculate it is cool, but if you can't explain it very well, if you don't understand what you're explaining, then it's a little bit harder to do good analysis on it. So the first thing that we're going to do is we're just going to head over to a Jupyter notebook. And this Jupyter notebook, you can find this exact one that I'm going to be doing in my GitHub, which is in a link below, and as well a file that we will be using. So what we're going to do first is we're going to be looking back at some data that I have, and I'll make this available in the GitHub as well if you want to follow along with this exact process. But we're going to be looking at the Europa League final from 2021. So it's Manchester United against Villarreal, and we want to look at all of the successful passes by Bruno Fernandes. We're going to be looking at all the successful passes that he made during the game, and kind of showing how we're going to take this process, filter it down, and then how we will calculate expected threat from there. So the first thing that we're going to do is we are actually just going to import pandas and NumPy. These are the only 2 packages we'll be needing. So we'll say import pandas as PD. So pandas is a library that allows us to upload the data as well as put it into a more tabular format. And then we'll say import NumPy as MP. NumPy is going to allow us to get arrays and kind of do some more calculations on everything. So we will import those, and then the data, to upload the data, we just want to create a data frame. So to do this, we just say df equals pd.read _CSV, so it's in a CSV format. And then the name of the actual file is called Europa final.csv. And we can read that in, and then to check it out, just to kind of see what it looks like, let's say df.head. So this is what the data frame looks like, and it has a minute, second, team ID, which is just the team name. The X and Y is where the first, where the action is beginning. Then the period, the type, the outcome, the player ID, so the player number. Bruno Fernandes is 18. So we'll be filtering down to 18. And then as well, it gives us an end X and an end Y, which is going to be actually really important for calculating expected threat. So to filter this down, there's a couple of things we can do. What we're going to do is we're just basically going to use AND statement, and we're just going to use something called .loc. So .loc is a pandas function that's going to allow us to filter the data. So to do this, we're just going to say df equals df.loc, and then square brackets, and then in parentheses, we need to say df brackets, and then the column name that we want to filter for. So first, let's filter for the team ID. I'm going to say outside of the square brackets is equal to, so 2 equal signs, and then pass in quotations, Manchester United. So I'm not going to be explaining a ton of detail of what this code is all doing. If you have any sort of questions about what this code is doing, I'll try and explain it my best as quickly as possible. But I do have other videos on the channel that you can check out that kind of explain more of this stuff in detail. So the next condition that we want to filter for is actually the player ID. So we'll say and then we'll just basically do this entire thing again, so you can copy it if you want. So we'll hit Control-C, Command-C if you're on Mac, and then we'll say player ID, so the column, and then we want to filter for, I believe he is number 18, but that is an int, so we don't put it in or whatever those are called, quotations. And then we will do it again, so we can just paste it again. And we are actually looking for passes. So we will say we want type. And then if we come here, we say pass. And then we want to do it one more time because we only want successful passes. You can measure unsuccessful passes too, but we really, in this quick analysis, we're just going to be looking at successful passes. So just paste that one more time. I'll come over here so it's a little bit easier to see. And then we want to say outcome is equal to, and then inside of the parentheses, we want to say successful. So just make sure you're spelling that right. And then just make sure everything looks good and run it. And so now if we were to run this df head again, this is what it would look like. As you can see, this is the first 5 rows of our data frame, and it's all Bruno Fernandes passes that were successful. So we filtered it down properly, and that's what our data looks like now. The way that we do expected threat and the way that we kind of calculate this is we use something called the expected threat grid. And this grid is basically just taken, and it's a model that's been able to attribute values to different zones on a pitch that allow you to quantify basically what the probability of scoring is from that zone. So if you go back to David Sumter's article, he actually has one right here. So this is the expected threat grid. So basically it's broken up into, I don't know how many this is. The one we'll be working with is an 8x12 grid. And this is basically just a model that's been built, and it's gone over years and years of data from matches, and it's quantified, okay, in this area, what is the probability of scoring? But as you can see, this is the probability of scoring, so basically really low back here, and then the closer you get to goal, whether it be this way or this way, the closer you're going to get is the higher probability you have of scoring, and obviously directly in front of goal is the highest probability. So what expected threat does actually, and the math behind it, is it's taking the starting value, so wherever the ball starts from, and the end value, wherever that is, and it's subtracting the two, and then it's giving you the difference, and that is your expected threat. So if we were to go from here to up here, so we're moving it from 0.025 to 0.031, that would be a 0.006 difference. So the expected threat of that action would be 0.006. So, and then expected threat usually is accumulated over entire games or over entire seasons. So you're able to quantify, okay, during this game or during the season or during, the string of games, what were they doing and how were they performing in moving the ball into more dangerous attacking zones. So in the GitHub, there's a file called XTGrid, and that is the grid that we'll be using to quantify and do the calculations of the X and Y to the end X and end Y. So if you open that up, this is what it's going to look like. And this is actually broken up into, just imagine that this is a pitch. So back here, you have the lowest zones, you have the lowest attacking probabilities. And then over here, you have the higher probabilities and the higher chances of scoring a goal. So it's going from left to right. So just imagine that a pitch is broken up into this many columns and this many rows. It's 8 columns by 12 rows. And so what we're going to do is we're just going to import this. So we say xt equals pd.read_csv, and then it's xt_grid.csv. And then we actually need to set header equals none so that it doesn't turn this first row into our actual column headers. So if we do that, then we can just see what it looks like. And it's exactly the same thing as what I was showing before. And so actually what we want to do is we want to break this up into an array. So what we'll do is we'll say xt equals np.array and then xt. So this turns it into an array. And then if we were to run this xt again, it changes to be like this. So an array is basically, this array is just lists of those columns. So this was the first row. This is the second row, third row, fourth row, fifth row, sixth row, seventh row, eighth row. So what we're going to do now is we're actually going to just get the shape of this so that we can kind of calculate some stuff. This is all just stuff that we need to be able to calculate expected threat. So we'll say xt_rows. So we want to see how many rows we have and how many columns we have. So we'll say xt_rows and then xt_calls equals xt.shape. And if we do that, we can see that xt_rows is 8 and then calls is 12. So we need these values because we're going to have to use them for when we're attributing to which zone a particular action took place. So to attribute that, what we have to do is we have to bin all of our actions up here. So we're going to create 4 new columns. It's going to be x1 bin, y1 bin, x2 bin, y2 bin. So basically what we're going to do is we're going to use this data up here, and then we're going to assign it to which zone or which bin it would be located in the x, so in the columns, which column it would be in, and then y, which row it would have been in. So we'll come down here and we'll create these 4 columns. So to do this, we'll just say df and then x1_bin equals pd.cut. So cut is how we bin the data. And then we'll say df x, and then we need to specify how many bins we want. So this is why we created this xt rows and xt columns. So our x values are associated with our columns because it goes along the x-axis. So we'll say bins equals xt_calls, and then we want to say labels equals false. So we set labels equal to false because we just want the integer location of the bin. So if the first x were in column 5, it would return a 5 on that same row. So we're going to do this 3 more times. We'll do it for x2, y2, and y1. So I'll just paste this 3 more times, and it'll be a little bit easier to actually do it. So just make sure that you're changing it. And then on all of the y values, we need to switch it to be xt_rows. So we'll come down here, x2 bin this time. So df, and then we need to do it for the end x. Is that how it is? Yeah, end x. And then we want the columns. That looks good. And then here we want y2 bin for our end y values. And then we need to switch this to be xt_rows. So that's what it should look like. If you need to pause the video right now just to make sure you got all that, I would recommend looking up what this pd.cut is doing. It'll be a little bit easier to show you after we run this. So now if we run it, we can go back into and look at df.head. Okay, so what this is doing is it assigned, if we were to break up the pitch into 12 columns and 8 rows, it is saying that this location, X, at 49.9 would have been in the 5th column, like 12 evenly spaced columns, and it would have been in the 4th row. So now that's how we're going to derive the expected threat value, is we're going to look at K, which column and which row, match them up, and that's how we get the expected threat value of that location. So to actually calculate this, we're going to use our NumPy array, and this is a little bit complicated, and I've had people help me with this, and there's been a lot of people that have helped me to be able to do this calculation properly. But we're going to do something called a lambda function and applying that lambda function to an entire column. So if you don't exactly know what this is, I do recommend looking up lambda functions a little bit. I had to do a lot of research and kind of digging into the code to make sure I understood what was going on. So to do this, we're going to get the start zone value, and then we're going to get the end zone value. So we'll say df start underscore zone underscore value equals, and then I need to make sure I type this right. So it's df and then 2 brackets, and we'll say x1 underscore bin, comma, and then y1 underscore bin. And then we need to say dot apply. So we're going to apply a function to both of those columns. And then we want to say lambda space x colon, and then xt. So we're going to use the grid. And then in brackets, we'll say x, and then bracket 1. And then outside of that, we will do another pair of brackets, and we'll say x bracket 0. And then we need to specify and say axis equals 1. So just a quick little summary, what this is doing is it is applying this function that we've created. A lambda function is kind of just like a temporary function that we use. And it's applying this function, which is essentially just going down both of these columns. So the x1 bin and the y1 bin. And it's going through and it's slicing and it's basically indexing and getting the value out of this array that we created up here. So it's going to go and it's just going to find the one that's located with 4 and 5. Mess with that a little bit, kind of see what's going on with it. And then for the sake of time, I'm just going to keep going. And then we're going to do the same thing, but for the end zone values. So we'll just copy this down, switch start to be end. So we have end zone value. And then we need x2 bin and y2 bin. So it's doing the same thing, just for the other columns, or for the other bins. So for our x2 bin and our y2 bin. So we run that, and then if we run df.head again, we now have the expected threat value of our first zone and our end zone. And then, like I mentioned, expected threat is basically just calculating the difference between the two. So we will say df and then xt equals df end zone, so end underscore zone value minus df start underscore zone underscore value. And we run that, and now let's run df.head again, and we scroll over and we have the expected threat value, which is pretty cool. So as you can see, this one was a pass that it was 7777, didn't leave the zone, so it has a 0 expected threat. Same thing down here, same thing right there actually too. He needs to start making some longer passes. Jeez, Bruno. It's Bruno Penandes for you. So if you wanted to, you could start getting the sum of the expected threat. So if you just said df.xt.sum, so his expected threat value during the entire match was 0.07. And this takes all the negatives, adds them to the positive, and this gives you the net sum. So that is how we actually calculate expected threat. This was definitely one of the more complicated tutorials because we used more advanced coding techniques with NumPy and Lambda functions and pd.cut. I mean, I had to go teach myself a couple of things to be able to do this, but hopefully you'll be able to take this code and be able to do it for yourself now. I know a lot of people have wanted this tutorial for a little while, so I'm glad that I was able to finally make it. That's it for this video. Thanks so much for watching. Any questions, be sure to drop them in the comments below. leave a like on this video if it helped you out at all. And if you made it this far, you're awesome. Thanks for watching all these videos. And yeah, see you. Peace.